understand this very carefully, guys. Okay, that if you have essentially you have a what is the goal? The goal is to find that given a sequence n, and we have to find the limit. So it consists of two aspects, whether the limit exists or not. So that's kind of a behavior kind of thing. But we will touch upon the ideas which will be detailed in the next lectures. But the other aspect is finding the limit.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
What I mean by finding the limit is that understand that finding the limit is not always easy. Okay. So if I randomly give you e to the power n into sine n by tan of cos n, as n tends to infinity, will the sequence be convergent? Will the sequence be divergent or whatever? What do you know? Okay. So understanding how to find the sequence limit is very important, and what are the techniques to go ahead with it. So we will be focusing today in this topic of finding the limit and the techniques to find the limit. The issue is that the problem we're going to solve is that so we have learned the definition of convergence of a limit. The question is that why is it not enough? I mean, we know you know that it's not enough, right? Because it's hard to find, like, to prove that it's convergent to that limit, we need to find the limit, right? So therefore, by in today's class, we will see that how to find the limit and also show that it's convergent. Okay, like probably we'll assume it's convergent. Okay, so the issue is that the convergence definition needs to have the limit. So we'll know the techniques out there. So now sequences can be defined in two ways. If you see broadly any sequence, it can be defined by two ways. Okay. Number one is the functional form, that an is just the definition, an is equal to f of n, and the functional form is given. The other is a recurrence relation form. Let's say an is equal to an minus 1 plus 2 by an minus 2, n minus 1. It's called recurrence relation. And I have talked about this in the last class. So we'll see how we can learn all these concepts and combine these two things together to approach the thing. So we'll go with the first one, okay, with the first functional form. Okay, we'll start with the functional form, that how to learn how to find the limit in the functional form case. So let's say if we have two sequence, let's say an example is that, let's say you have a sequence, let's say 1 by n, you have seen last 1 by n, this goes to 0, right? And we've also seen that by the definition in the last class, 1 by n square goes to 0 as n tends to infinity. The limit is 0. Now if I give you 1 by n plus 1 by n square, and instead of writing this, I write this in this form, okay, n plus 1 by n square plus n. Now understand that you have to again use, like, do you have to again use that whole concept of limit and all this epsilon to prove it? Probably not. There's a better way out. And the basic idea is that when they're algebraic, like, it's nothing but some function of n, and it's nothing but another function of n, and we are adding it up. So the natural question comes that, so essentially understand the basic idea is that when functions, there are two functions f1 and f2 which defines two sequences, let's say an and bn. You understand? For here the function is 1 by x and here the function is 1 by x square. The question is that two functions can interact with each other in any different possible ways. How many ways two functions can interact with each other? If you have learned group theory, you will see this is a very famous problem in group theory, okay, famous example, the set of all functions. So two real functions can add itself together, two real functions can multiply itself together, two real functions can divide itself together if f2 is not equal to 0, and two real functions can subtract itself together. The question is that when two such functions of sequences interact with each other, okay, like this algebra in this group of sequence, so all the group of functions can always interact with each other in these four possible ways. Okay, also there is composition. We'll talk about composition too. So we'll see how to deal with these things, how to deal with these scenarios. Okay, this is really interesting. So understand, functions can interact in the five possible ways. Functions can interact in the five possible ways. What are the five possible ways? Number one is addition, subtraction, multiplication, division, and composition, right? Any other ways you know real functions? No, right? This is only three ways composition. For example, f of 1 by n is f of 1 by x is a composition of f and 1 by x, right? So we'll see that so therefore understand a sequence is defined by a function, right, f of n. So therefore to create another sequence can be nothing but, so you have another sequence, it's a bn, which is this is f1 of n and this is f2 of n. we can create another sequences from these sequences using these operations, right? Let's say gn, it's nothing but f1 star f2, where a star this is can be any of these operations. You understand? Then how to find this limit? Because it's a new function. But so essentially the new limit cn ka limit will be based on like this f1 ka limit, this f2 ka limit, and the star function, right? Do you understand? You understand the core idea, guys? If you define the sequence as a function, so the functions can interact in these 5 possible ways only. So therefore, a new sequence can be made from 2 different functions by this f1, f2, and star. So therefore, new limit will be based on this f1, f2, and star. So therefore, we will see that how to find this, because it's just natural generalization of the ideas, right? So it's called the algebra of limits. It's simple, just simple story making happening. Like this is how human beings think. If you see any dimension of mathematics, it's exactly like this. For example, the same thing. If you remember, for differentiation, if you have done in your school days, we have differentiation for plus, minus, multiplication, differentiation f dash g plus g dash f, division f by g, f I forgot the formula, and f compose g, that's a chain rule, right? So all these things, so the algebra, this is called the algebra of functions. From the algebra of functions, because the operation of limit is on functions. So you can see this is called the operator theory in mathematics, that so there's all function set, right? Now on this you're applying an operator. It can be differentiation, it can be limit, it can be any other thing. So essentially on this function set, so therefore you will see this is general trend in mathematics, or if you see any mathematical theory developing up, you will see that this on this measure set, however they're interacting, we will see how the operators are behaving according to that. And that is very important, guys. Okay, this is very, very important, because this the operator should interact, this operation should interact with the algebra of this. That's why it's called the algebra of limits, algebra of operation. That's why in differentiation we'll call algebra of differentiation. In integration we'll call algebra of integration. Okay, probably in f compose g the integration is not there, but we can do it. Yeah, f compose increase is nothing called the substitution rule. Okay, so these are all the algebraic methods. So you should have a common theme out there when you're studying anything. So this is my role as a teacher, that to tell you the common bird eye view, that what's happening all over the field and interaction with it. That's where your creativity will fall in when you're leading a new topic. So this is, remember, the central theme, the operation and the limit, the algebra and the limits. Okay, so the basic idea is that the algebra of the operation. So the algebra comes from here and the operation comes from here. Sorry. So we'll say the algebra of operations, right? And that's it. Okay. So now just find it. It's very easy. 5 operations, you know. So it's nothing but if an goes to, so it's, you can assume that an is equal to f of in. So an is equal to f1 of n, and bn is equal to f2 of n. We're assuming that a and bn are, let's do for plus, minus, this, division, and composition. So 5 things, an plus bn. So we are assuming that an goes to a and bn goes to b. So the new function which is defined by an plus bn, that is f1 n plus f2 n, that is f1 plus f2 function, that goes to a plus b. This goes to, so you can see, you can connect everything, that why it is developed the way it is developed, because of this general thing, basic easy thing. So I'm not going to do the proof of this. Okay, this proof you can find from the book. Read the Kineteros or the Stephen Abbott. Okay, that's the reading material. If you want to know, the proof is done using epsilon delta. That's where, so therefore understand the role of those epsilon things, epsilon and n epsilon things will be using, we will be using those to prove these things, so that we can generalize the whole thing. This is like a technology. Okay, this is like a Tesla car. Okay, you can use this for many things. So essentially theorems in mathematics are like technology. Okay, so the use of technology is nothing but it can help you fasten up your process of anything. So I connect engineering and mathematics in this way. Okay, that this is how, like, a theorem is nothing but a technology that can help you do your work much more easier way. So your goal is to do the work of finding the limit, and these theorems are nothing but helping you and aiding that in the process. Okay, and similarly an by bn goes to, if bn is not equal to 0 somewhere, or yeah, if bn is not equal to 0, and f compose is interesting. Now f compose is interesting. It tells you this, that now you will learn about this in later on classes, but it's telling, the theorem is that if f is, say, f compose gn, okay, this is not, you understand this, or f compose f like this, this goes to f1 of where f2 goes, or yeah, this is called bn, so where b goes, if f1 is continuous. So that means limit of n tends to infinity f1 of bn is equal to f1 of limit goes inside the continuous function if this happens. There are other cases too, but this is like the sufficient condition. So therefore limit goes inside. So the limit and continuous function interchange. Okay. So this is the algebra of limits. All of you understood this? And this is very easy, guys. This is very, very easy. And this is, you understand the basic idea. Okay. So this is the basic thing out there.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.